Okay, in this video, we are going to talk about the motion of a charge in a region where both electric and magnetic fields are present. So we will consider in this way that the electric field, it is acting like this. That means from positive plates, because we know electric field is usually produced from negative to positive. That is the directions of electric field. Suppose I have two parallel plates, one is positive and one is negative, arranged in this way, then my electric field will be directed up in this way. Okay, so this is my directions of electric field. So again, in this region, we have a magnetic field which is perpendicular to the plane of the board, like this. So as I have already mentioned before, that the directions of magnetic field which is perpendicular to the plane of the board, it is shown by the cross here. So electric field is acting, in this way. Magnetic field is acting in this way, perpendicular to the board. So in this type of field, if I have, let's say, an electrons, okay. Now suppose if this electron, it is entering this region with the velocity v. So what happens to the motions of the electrons? Because we know, due to the electric field, the electrons will experience an electric force which is QE, but in this case the charge of electron is E, so I'll write EE. Okay, and the directions of this force which is experienced by this electric field, it would be towards the positive plate of the field, because we know electrons is negative. So when there is a force acting on the electrons, so that means that force will deflect the electrons towards the positive. That means electrons is moving down. Now, because in this regions we have not just electric field, there is also an electric field. I mean, there is also a magnetic field. Suppose the strength of the magnetic field, let's say it is B. Now, because of the presence of magnetic field, again, there will be a magnetic force acting on the electron. And we know magnetic force is equals to QVB sine theta. In this case, instead of Q, the charge is electron, so we write E. And what is theta? Theta is the angle between V and P. Initially, the angle between V and B, it is 90 degree. So sine 90 is 1. So I'll remove this. So these are the two forces, okay, experienced by the electron, right, from electric and magnetic field. Okay, I have not indicated about the directions of the force due to this magnetic field. Due to magnetic field, if you apply, Fleming left hand rule, this is my magnetic field. This is the directions of motions of the charge. Initially, it is trying to move in this way. So the force will be acting up due to the thumb. The thumb is acting up. So that means, the magnetic force here will deflect the electrons up. Okay. But you will also find, suppose this is not just one electron. Suppose I have a beams of electrons which are entering into the fields. So when a beam of electrons are entering into the fields where electric and magnetic fields are present, then you will find here some electrons are moving straight like this, right from the starting point till they come out of the regions. The direction does not change. Some electrons can do that, but not all. So if for such electrons which is moving straight in this way, it means that happened only in the region where both the electric field and the magnetic field are equals to each other. Which means EE is equals to EVB. So this E from the left, E from the right. So I can say E is equals to VB. Okay. So please note down this equation. So you get this equation to only when the electric force and the magnetic force are equal to each other. So if both electric and magnetic fields are and magnetic force are equals to each other, then the charge will move straight without any deflection. Okay, so from here I can also say V is equals to E upon B. So this equation also, it's very important. Sometimes they may ask you in exams as a numerical problems to determine the velocity of a charged particle which is moving in a region of both electric and magnetic field, and the electric and magnetic fields are equal. So you have to use this equation.